Hello, a very warm welcome to all of you, my viewers. So, starting with the next class of linear equations in two variables. So, far we have finished the general idea of linear equations, and we have finished with one of the method, that is the method of substitution. Today, I'm going to start with method of elimination. So, first of all, I'll be explaining you in the general form and the general equation, and then we'll go for solving more problems of this kind, right? So first of all, let's go to the general discussion. So one of the equation I consider is a1x plus b1y plus c1 equal to 0 with the conditions. The other equation is a2x plus b2y plus c2 equal to 0. Now, if I am applying method of elimination, then first of all, we must know what elimination means. Elimination means to remove one of the variable here. Elimination means to remove something. So here in this method of elimination, the prime idea is to remove one of the variable first in order to simplify the whole process, right? And when we try to remove one of the variable, it's up to you which variable you want to remove first. There is no hard and fast rule. But what I explain here is for removal of x in the general form, right? So for removing that variable x, once you decide, your first task is to make the coefficient of x in both the equations equal. So instead of saying elimination, we can say that this is a method where we make the coefficients equal and then we eliminate, right? Elimination by making the coefficients equal, right? This could be the another name. Actually, it is there, but now presently we're talking about is an elimination method. So we have decided to make the coefficient of x equal, right? In the first equation, the coefficient of x is a1, and in the second equation, it is a2. Now, the simplest way of making them equal is that simply multiply the coefficient of x in the second equation with the first, and the coefficient of x in the first equation with the second equation. That's what is the easiest part. In that case, very readily you will be getting the coefficient of x equal, right? So that's what I did here. Equation number 1 has been multiplied by a2. Then I would get this is a1 a2x, then a2 b1y, and then a2 c1 is equal to 0. In both the sides you have to multiply, right? Right side there is a 0, so there will be no change at all. This equation we have marked as 1 prime. Then the other equation 2 is multiplied with a1. Then I would get this is a1 a2x plus a1 b2y and a1 c2 equal to 0. That is the another equation we obtain once we multiply. What next? Once we get the coefficients equal, right? Now if we subtract this term or this term or this term from this term, what we'll get? We'll get a 0 for that, right? They will get cancelled. So that's what is the trick here. So 1 dash minus 2 dash, if I do this term will get cancelled here, and then entire left side term of the first equation, here it is written, minus this term here will be equated to 0. Did you get me exactly what I did? And be very alert once you are doing a minus subtraction, then you must put a bracket here as I put here, otherwise it may create a problem with this particular plus sign, right? Now after that what I did, I removed the bracket. So removal of bracket will do what? If there is a minus sign in front of the bracket, it will change the internal signs, right? So this is going to be minus of a1 b2y, and this is a1 c2, correct? Then what we did, we collected the like terms. These are like terms where y is present. Fine. And then we collected y together. So this becomes the coefficient of y, and the other part, which is a constant, will be pushed to the right side, and then simply you divide that right side by this quantity. You'll be getting the value of y. Fine. So what did you observe? Once you try to eliminate x, you'll be ultimately left out with the single value y. And had you eliminated before only the variable y, you would have got the value of x here. So that's not an issue. You start with any one of them and end up with the other variable's value. And once you get the other variable's value, you can put this value in either of the equations which are given here to find the missing variable so far, right? Is that clear to you? So that's what the general method is. Now I'm going for taking some questions and I'll explain you again the complete method. I do hope that you'll be able to grasp it very clearly. Okay, let's move on to the next question. Okay, that's the first question of method of elimination, right? So, as I told, I did not tell you perhaps, but in method of elimination, one thing you should be very careful that both the equations should be always in the same format. It's not necessary that something is in the right side, something is in the left side, not problem. But thing is that both the equations should be in the same format, like this is the case. In our general case, the constant is kept in the left side, but here it is in the right side. There is no issue at all. So I would like to mark this equation as 1 here itself, and this is 2. Great. Now you have to just think to start with the method, which variable you would like to eliminate. There is no hard and fast rule, as I told you earlier. So normally people tend to remove x. So I'm also doing the same thing. I'm going to remove x first, then I'll get the value of y, right? So what is the coefficient of x in the first equation? It's 2. What is the coefficient of x in the second equation? It's 5. Now you can easily see that the first equation, if you multiply by 5, then you will arrive at 10, and the second, if you multiply by 2, you will arrive at 10. Meaning is that you have simply exchanged the coefficients of x as the multipliers. So you write this precise statement. Equation 1 is multiplied by 5. Then what will I get? You have to multiply each and every term. Remember it. This is 10x. Then this will be by 5 if I multiply 15y. And then by how much I have multiplied this by 5, right? It's 95. Okay. And then equation 2, I'll multiply by what? 2. I'll be getting this is 10x. This will be 8y. And then 37 into 2, 35 into 2 is 70. And this gives you 74. That's all. This can be marked as 1 prime, 2 prime, right? You can call it as 1 dash, 2 dash also. And now my task is to subtract. From 1 dash, I'm going to subtract 2 dash. Now you see, this number, this term will get cancelled with this because this equation is subtracted. So all the preceding sign will get reversed. Did you get me? So they will get cut. Now this is 15y minus of 8y gives you how much? 7y. Great. Then 95 minus 74. 95 minus 74. How much you will get? It's 21, right? It's 21. So what is y equals 21 by 7? That gives you 3. So ultimately where you will end up is the value of y. Great. Therefore, now you use any one of the equations. You got 4 equations in hand. So I'm going to use in equation 1 the value of y, right? So that I can find what is x. So this gives me this particular result. In equation 1, I replaced y equal to 3. So twice x will be equal to 19 minus 9, leading me to x equals to 10 upon 2, that is 5. Therefore, at last, conclude it x equal to 5 and y equal to 3 is the solution. That's great. That's great. Okay, now just I'll take 1 minute for explaining more something. There may be a question that once you finish with 3, do we need to apply the same sort of idea of elimination of the variable y like this in order to find the value of x? That question should eventually come to your mind. If it is not coming, then okay, fine. Actually, the method says that we should do that. But as the marks is also a concern, we do not go for that. But if you can carry on with that, it's always welcome, right? I mean, here, like I have eliminated x to find y, and the other part I can eliminate y in order to find x. Okay, move on to the next problem, please. Yeah, this is 4x minus 3y equal to 32. Number one. This is number two. Already they are in the same format, so I do not have to think much of them. So I can directly start with elimination method, right? Now here you see, choice will be again yours. Which variable you would like to remove? This time, I would say that I'm going to remove y first, right? There is no specific reason, but if you see, you'll be identifying it easily. First of all, I'll have to simply multiply this by 3 because this is already 3, right? If the numbers are 1 here, it is advantageous for us. So equation 1 remains untouched. How will you show that it is untouched? That means you have multiplied this equation by which number? 1. This is 1 dash, and then next equation 2 will be multiplied by 3. Achha. You may ask me why not minus 3? Yeah, you can go for it. I don't want to go for multiplying it by minus. I just multiply it by 3. Let me try to tell you what is the advantage here. If you would have multiplied by minus, you were needing to subtract this equation. But here you see, as I did not multiply with minus, simply they are having opposite sign, which tells me that I can add these two equations. Great. So this is 7x, they will get cut, and then this, if I add, how much I'll get? 35, leading me x equals 5. Great. Now just you have to think for y. So you choose any one of the equations from the top. I think you are thinking about choosing equation 2. That's the thing, because it's the most easiest out of all the 4 equations. So you can write, therefore equation number 2 implies put the value of x very comfortably and find what is y equals. So at last, how will you conclude? X equal to 5 comma y equal to minus 4 is the equation. Great, right? So that's what we end up with to find the solution. So till now, I do hope that you are finding it not difficult. It's actually a comfortable method, and it's much more like advantageous to get this method used in some of the problems. We will be getting coefficients as some numbers instead, sorry, coefficients as some letters instead of numbers. Okay, we'll be taking up those problems also in the next 2-3 subsequent periods, right? Okay, this is another problem. So I think I do not have to waste time in doing this. You can do it yourself. I leave this for you as a homework. Okay, apart from this, you should remember that you should go for your class homework as well as your textbook homework also. I'm not covering all the problems of textbook. I'm just covering the methods. I'll be doing some problems which are from outside books, which are little higher orders, right? and then you have to do the problems of your book yourself. Okay. Another problem solved by method of elimination. Okay, it's again I'm telling you that if I do these problems, it's wastes of time. Okay. Yeah, that's a good problem because this is coming with some of the statements. I was looking for this kind of problem only because statement problems are real genuine problem which can create a problem during your exam, right? Let's read the question. A father's age is three times the sum of the ages of his two children. Be very clear. I would like to mark this problem as important one. A father's age is the sum three times the sum of the ages of his two children. Remember it. After 5 years, his age, right? His age will be two times the sum of their ages. Their ages means the children's ages, right? It's not very clear. The present age, find the present age of the father. Okay. I see. Usually, when we do a problem, we are told about either a boy or a girl as a son or daughter. But here you can see that we are talking about two children. So that's the important point, and that's why I marked the problem as important one. Be very alert while doing this. Otherwise, there is a very good chance of committing a good mistake here, right? So here they are asking you the present ages of father and the sorry only father, right? So first let me write let the present age of the father be x year, and the present ages of the two children, remember it, be y years. Two children, I have said this is the combined age of two children, right? I'm not considering both their ages separately. Not needed to introduce any third variable here, right? Now, according to question, first condition, what it tells. Father is three times as old as, right, the sum of the ages of the children. So father's present age is x. This should be three times of y. This is one of the equation, right? Great. And now you have to go for the another equation. I'll do is rough okay here because that's very important. Here is the only part where the mistakes may be committed. Now they are talking about the age of both father and the children after 5 years. Just you imagine if your father is X years old presently, what will be the age after 5 years? Yeah, you have to simply add 5 to it, right? Okay. Equally, these two children will also grow up, right? So what will be the age together, right? We're talking about the sum. Present age is 5 years both, and then after 5 years, what will be their sum? What will be their sum of ages? It is y plus 5 years. Exactly. That's where the students commit a mistake. Had it been only one child, it could have it would have been correct. But remember, you are talking about two children. That's the main part where students commit a mistake. They add 5. But do you think really we have to add 5? Wrong. We have to add 10 because if you're talking about the age after 5 years, don't you think that both the children will grow up by 5 years each? So what will be added to their ages when you calculate after 5 years? Obviously 5 each. So total addend will be 10, right? So after 5 years together, the children will have a age y plus 10, where fathers will be x plus 5. Now you can compare. So father's age is x plus 5, and that's this time two times the sum of his these children. Now what you get is x plus 5, that gives you twice y plus 20, leading you ultimately to x minus twice y, and then right side I keep the constant. I'll transfer the 5 here, so it will be 5, 15. So you got two equations. Now as I'm doing it under the method of elimination, you can proceed for doing that, but I would suggest you, if no methods is specified, it's very good to use here in this particular equation the method of substitution, because already your substitution is ready. Or else if you do like elimination method, then this equation will be taken this shape. Right? Instead of writing like this, you can come here, you can mark this one, and then you can already see here another advantage is here that the coefficient of x is already equal, so you can directly subtract also, even if you apply the elimination method, right? So I do not want to complete the problem left for you. Please do this, right? Okay, next question is regarding a fraction, right? The sum of the numerator and denominator of a fraction is 4 more than twice the numerator. Here absolutely I'll not write the statements. You can write the statements very well, so I'm writing only the mathematical part. A fraction will be looking like what? X by y. So at the beginning only you write that let the denominator be x, numerator be y. So this is the fraction according to question. The sum of the numerator and denominator of the fraction is 4 more than twice the numerator. It's equal to 4 more. 4 more means 4 should be added to whom? Twice the numerator. Numerator is x. So ultimately, if you reduce this equation, you are going to get this equation. So this is one of the equation you get. Next, if 3 is added to each of the numerator and denominator, their ratio becomes 2 by 3. 2 is to 3, right? If you are adding 3 to both numerator and denominator, then it becomes 2 by 3. Now get the cross multiplication done, right? You know about the cross multiplication. Already you got in lower classes perhaps. So we got it, and then we'll try to simplify this, right? So what I'll arriving at, this is 3x minus twice y plus 3 equal to 0. So now you see there are two very good equations. And now as for your wish, because there are many ones here, both the coefficients of 1, you can choose this to multiply. Maybe you are going to multiply 1 with 3, maybe you are multiplying number 2 with 2, or 1 with number 2. Choice will be yours, absolutely, right? I do not want to complete the problem again. The rest is homework, please. So don't mind, I'm leaving many more problems for you, because I'm sure that you will be able to do this. Okay, another important problem. This is a board problem. Already in board it came. I think it came in the Delhi board. The ratio of income of two persons is 9:7. The ratio of their expenditure is 4:3. If each of them manage to save rupees 2000 per month, find their monthly incomes. Okay, first of all you try to observe. If a person here extra incomes or extra expenditures are not shown. It's what shows is the correct one. You have to accept it. That whatever is the expenditure and the saving together, if you make it, that is the net income, right? So now I have to just find what is the monthly expenditure as well as income for both of the persons. So now at the very beginning only you can consider if the ratio of the income of the person is 9:7, then I can consider let the monthly income be 9x and rupees 7x. Whose monthly income? By the way, you have to talk about the persons. Person's monthly income with this. Okay. And that is a multiplier, right? X ratio. And the monthly expenditure B कितना होगा? What will be the monthly expenditure? 4y and rupees 3y. Am I clear to you? Now you see, according to question, 9x is the amount the first person earns, out of which he is going to spend 4y rupees, and then he saves rupees 2000. This is number one. Similarly, the second person earns rupees 7x. He is going to spend 3y rupees, and still he will be having 2000 in his pocket. So once you form these two equations, your task is done. Now choice is absolutely yours. Which variable you would like to eliminate, and then you proceed for multiplication. But I'll suggest you, because the numbers, or that is the coefficients associated with y is less, you try to evaluate, eliminate y better. So for that, you'll multiply 1 by 3 and then 2 by 4, right? So with this you proceed, right? Again, I'm leaving you in between, so don't mind, just do it, right? Maths is more about doing instead of listening someone doing that, right? Or seeing someone doing that. Okay, I'm coming to the last problem of, in fact, this method as well as this period. That's an important problem. Again, I would like to explain you this, and you be very, very alert. This is again a very important problem. It tells test you the real concept, right? 2 points are A and B are 100 km apart on a highway. One car starts from A and another from B at the same time. If they travel in the same direction at different speeds, they meet in 5 hours. And if they travel towards each other, they meet in 1 hour. What are the speeds of the two cars? There are two cases, right? I'm going to discuss with both the cases. I'll get up to the equations. Solution is your business, right? So for this, I'm doing a scheme here. This is the point A. This is the point B. Both these points are such that their distance is 100 kilometer between them, right? There are two cars. One car is here, another car is here. First case, you see, they travel in the same direction. Let me try to consider that both of these are traveling in this direction. So even they are starting at the same point, same point of time. Both the cars are going to meet after certain time. What is that certain time? 5 hours. After 5 hours, they will meet at the point C. What does that indicate? The car at A will be having higher speed because in 5 hours it will cover this much, whereas the car at B will be having lower speed because in 5 hours it will cover this much. So what I mean to say is that you have to consider at the beginning only one car with bigger speed. Choice is yours. You can consider the other one. In that case, this figure will go in the opposite direction. So here what I did is that speed of the car I will consider as x kilometer per hour, which is at A, and speed of the car at B I'll consider as y kilometer per hour. Right? Very fine. Then, as it is a problem of speed and distance, let me again try to tell you Once it is a problem of speed and distance, you always have to use this formula. This is a physics formula already you got. Speed equal to distance by time. Anyhow, right? So we have to find that particular relations. Here you see what are the events given. This was the case 1 actually. So I already have made my suppositions that the first car is having speed x kilometer per hour, y is the speed of the second car, and x is bigger than y, right? So for how many hours you are allowing them to drive in the first case? 5 hours, because before that they will not meet. Now supposing that the car at A is driving at the speed of x kilometer per hour for 5 hours. How much distance will it cover? Speed is x, right? Distance I have to find, and the time I am giving you is 5. So how much distance will this car be covering in 5 hours? 5x, meaning A to C, this distance will be 5x. This is the complete distance, right? This is complete distance. And that distance is equal to, you see here, compare 100 kilometer plus this distance which is covered by B. So in 5 hours B will cover how much? 5y. So now from here you cancel 5 from both, so it will be left out with this equation. If you'd like to write it in the form of the standard equation, you can write it like this. Choice is yours, it is not necessary at all. So wait for some time, check it whether you have understood this particular way or not. This is case 1. Case number 2. In case number 2, what happens, I'll change the color of the ink so that you'll be comfortable with this, right? You can make a difference. Okay, come back. I did not show you how I did the change of color of ink, right? See, now this time the cars are at these points only, but they are allowed to move in the opposite direction. Speed remains the same because they have said that instead of moving in the same direction, if they will come to each other, they will meet after 1 hour. So our supposition says that this is bigger. So if both the cars are allowed to move for 1 hour, then very obviously the car at A will move little more distance than the car at B. So suppose that in this case both the cars will meet at this point. Now can you find how much distance is covered by car at A in 1 hour? This is the distance, and that is how much? It is x into 1. That is simply x. What will be this? 1 into y. Together these two values makes how much? 100. So your other equation is this. Sorry, here earlier I made a mistake. You please correct it. So this is 100. Number 2. Now you got equation 1 and 2, and hooray, that's the case. Solve them, and just see whether you get the answer or not. So the task I want to leave with you is just go through the exercises. I'm going to take in the next period the method of cross multiplication, and then I'll let you know what else or what extra problem I'll be doing, right? All the best, guys. Bye.